Now that we have done designing the column, the questions ask us to sketch the detailings of the column. In order to sketch the detailings for the column, you will need to look back into the solutions to the example and extract the relevant informations so that you can present them graphically. First, based on the design, you know that you need 4H12 as the main reinforcement. As for the shelling, it will be R8 200 throughout the column. And at the lapping regions, as well as at the regions near to the joint, the spacing it will be 120. Based on the information available, you can sketch the cross sections of the column. The question gives you the size of the column equals to 200 times 200 as indicated in the question here. Draw a square sections, indicate the dimensions 200 times 200. There will be 4 reinforcement bar, 4H12. And then you have the shelling, R8 200 throughout the column and R8 120 at the lapping region. Remember, when you sketch the shelling, there should be a tie here. The shelling should go something like this. In order to ensure they don't get loose when the column is subjected to compression. To clearly show the differences in terms of the maximum spacing, you may sketch the detailings something like this in order to demonstrate your understanding. This will be the main reinforcement, which is 4H12. Assuming that you are providing the same amount of reinforcement bar, this will be the main reinforcement for the upper column, which is also 4H12. Normally, the columns are cast story by story. In terms of the sequence of the casting, normally you will cast the column up to here before you proceed with the casting of the beam, and then followed by the casting of the column. You may have your main reinforcement bar continuous throughout various stories, but this is relatively hard to manage from the practical considerations. Since your column casting it will end here, you will have to extend the reinforcement bar from the lower columns to the intended length, where the lapping length is sufficient, with the main reinforcement bar from the upper column. You need this lapping length so that the stress can effectively transfer from a reinforcement bar to another. This is to ensure the continuity of the members. That's why you will need to sketch the lapping part here. Label the reinforcement. Next, you will need to sketch the shelling. The shelling is represented by the horizontal lines here. Throughout the column, the shelling it will be R8 200. Reaching to the joint between the columns and the beam at the height of H, which in this H it will be the size of the column, the bigger dimensions of the column size, which in this case 200s times 200s. The H it will be 200. At these regions, you will need to make sure the spacing provided shall not exceed 120. You will have shellings more closely spaced within this region. Sketch and label this. With that, this gives us an idea how the reinforcement should look like in the column as well as at the joint.